Welcome to the Level 3 video on repeated integration. Today we're going to be discussing variable limits. Okay, so we know that for more complicated domains of integration, this is where we don't have separable or fixed limits. It is necessary to have variable limits. Okay, and in this case, the limits of integration cannot be directly changed. So when we looked at fixed limits, it actually transpired that it didn't matter which way around we conducted the integration, but when we have variable limits, it does. So let's look at a quick example so we can see what we mean by a variable limit. Okay, the example is express the following triangular domain of integration in both orders. And if you don't know what I mean by both orders, that will all become clear in a moment, hopefully. For the region where this is x and this is y, the region from 1 to 1, and our solution is the following. Okay, so first of all, let's consider the x direction. Okay, so we're trying to work out what our limits are here. So looking at the x direction, we can see that x ranges from 0 to 1. Okay, very simple. Here we have x is 0, it goes from 0 to 1. And then we have to consider the y direction. Okay, and y ranges from 0 to 1 minus x. Okay, and why is this true? This is because the equation of the line so we draw the graph again, our x-axis and our y-axis. This is 0, this is 1, this is 1. The region is called R, and if we come along to this point here and work up and read across, this point is x along and 1 minus x up, okay, because the equation of the line is y equals 1 minus x. Okay, but let's consider now the y direction first. So y ranges from 0 to 1. Okay, and then we want to consider the x direction, and x ranges from 0 to 1 minus y. That's because we're going to be at the point 1 minus y and y. Our double integral over the region R of our surface f with respect to y and then x is the integral from 0 to 1 with respect to y, and the integral from 1 minus y to 0 with respect to x of this function, the x dy. Let's look at another example. So find the double integral over the region R, the function xy with respect to y and respect to x, where R is the quarter circle in the following diagram. So here is our diagram. This is y, and this is x. This is the point 2 and minus 2. Do my best to draw a quarter circle. Okay, so that's meant to be a quarter circle. This is our region R. So let's calculate the solution to this. So just as we did before, let's consider the x direction first. So x ranges from 0, we can see it's 0 there, to 2, and then for the hard bit, then we consider y, and y ranges from minus the root of 4 minus x squared to 0. And this is because the equation of a circle is x squared plus y squared equals r squared, the radius. Our radius is 2, so this is equal to 4. So if we're thinking of a point x along, which is our region R, and we draw this down, so this is the point x along and minus the square root of 4 minus x squared down, because when we solve this equation for y, we have 4 minus x squared, take the square root, but we want the negative because we're looking below the x-axis. Okay, so let's go and consider the y direction now, because we've just considered the x direction first. And y ranges from minus 2 to 0, and then we consider, of course, the x direction and x x ranges from 0 to the root of 4 minus y squared, and this is for the same reason as before. This is because the equation of a circle is, of course, x squared plus y squared equals r squared. The radius was 2, so this is 4. And our quarter circle, defining our region R, if we draw across a point here at y, this point is going to be the root of 4 minus y squared along and y down. Okay, so that's this time solving this equation for x. So 4 minus y squared all square rooted gives us the square root of 4 minus y squared. And we have to remember whichever direction we actually consider first, whether it's x or y, we're always going to get the same answer. And our double integral over the region R of xy with respect to y and respect to x, we get the double integral from 2 to 0 and from 0 to minus the root of 4 minus x squared xy with respect to y and respect to x. And it's worth noting that this is computing the double integral, considering the x direction first. And let's go ahead and compute this example. So the first integral we're going to do is the integral on the inside. So we're integrating from 0 to minus the root of 4 minus x squared with respect to y. And then we're integrating from 2 to 0 with respect to x. So like we said, we do the y integration first. So we have a factor of a half coming out, and we have the x integral remaining from 2 to 0, and xy integrates to xy squared between our limits. And we can substitute some limits in, and we're going to get 0, and then of course minus root of 4 minus x squared. So we have x times 4 minus x squared, still integrating with respect to x, and then we can multiply this out and get rid of the minus sign. For x, integrating that with respect to x. Let's keep our half out front. We have x to the 4 over 4 minus 2x squared between 2 and 0, and when we substitute 2 and then take away nothing, we're going to get minus 2. Alternatively, now we can consider the y direction. First rather than the x direction, so our double integral over the region R of xy with respect to y and respect to x is now going to be the integral from 0 to minus 2 and the integral from root of 4 minus y squared to 0 of xy with respect to x and respect to y. And again, we can split these up for clarity. So we're integrating with respect to x between root of 4 minus y squared and 0, and with respect to y between 0 and minus 2. So let's go ahead and compute this integral with respect to x first. We can pull out a factor of a half, and this integrates to x squared y between our limits, and we substitute these in, and we'll have the half still 4 minus y squared times y. Multiply this out, and we have 4y minus y cubed, and we can completely compute this integral with respect to y, and we have a half 2y squared minus y to the 4 over 4 between 0 and minus 2. Substituting 0 and minus 2 into this, we have a half 0 minus 8 minus 4, which is 4, or minus 4, and then this divided by 2 is again minus 2, which is consistent with the previous answer. Thanks very much for listening.